Hello everybody, we're getting ready to do lesson 11.5 part 1 pre-calculus math classwork lesson. And for today's lesson, you got 6 points in your notebook guide or your notebook, and then we got 42 points on your classwork sheet. Have your classwork sheet out, ready to go. And then student, put your name, date, period, onliners, due date, downliners, and homeschoolers. Into our lesson today, we start right off with a notebook entry here. Limits of summation. So earlier in the text, you used the concept of a limit to obtain a formula for the sum S of an infinite geometric series, like this here. I mean, this is your formula for finding the sum of an infinite geometric series. S equals A1 plus A1R plus A1R squared plus dot dot dot. And this amounts to a summation here with an upper limit of infinity. And I equals 1, A1R, I minus 1 equals A1 over 1 minus R. And the absolute value of R is less than 1. Using limit notation, this sum can be written as, the sum here again is the limit as n goes to infinity. The upper limit level now of the summation is n. I equals 1, A1R, I minus 1. And then this reduces further to the limit as n goes to infinity for A1 multiplying by quantity 1 minus R to the nth power over 1 minus R. And then this eventually becomes just A1 over 1 minus R. So this is the limit R to the nth power as n goes to infinity equals 0 for 0 less than or equal to R, less than or equal to 1, absolute value of R. So when you have that condition there, then it is equal to 0. You know that right off the bat. Okay, so there's some rules there. The following summation formulas and properties are used to evaluate finite and infinite summations. Summation formulas and properties. So this property number 1, we have an upper limit here of n, and then I equals 1 summation c, and then c is a constant in this case, so we can just multiply c times n, and we can get our summation from that. And then 2, we have upper limit here of n, and then I equals 1 for this summation I, and then this becomes n times n quantity n plus 1 over 2. Property number 3, again, we have upper limit here of n, I equals 1, I squared now equals n times n plus 1, and then 2n plus 1 over 6. Then property number 4, we have an upper limit here of our summation of n, I equals 1, I cubed now is n squared times quantity n plus 1 quantity squared over 4. Property number 5, when we have upper limit of n, I equals 1 of this situation here, a to the I plus or minus b to the I, and this will become upper limits here of n, I equals 1 ai plus or minus summation of upper limit here of n, I equals 1 of bi here. Property number 6, we have upper part of this summation of n, I equals 1 kai, and then we'll bring this k out in front. It'll be k times upper limit here of n, I equals 1 ai, where k is a constant. So those are some very important properties of summations. Evaluating a summation, evaluate the summation. So here's our summation. We have upper limit here of 200, I equals 1, I equals 1 plus 2 plus 3 plus 4 plus dot 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 200. So we need to evaluate this summation. How will we do that? So we're going to use this rule here, rule number 2. When we have an I out in front here of our summation, this would be the formula that we would use. Using formula 2 with n equals 200, you can write this summation as n plus 1 over 2, and then we plug in here we get these numbers here, 200 times 200 plus 1 over 2. This would be 20,100 is what this summation would be, using this very important formula right there. Let's try one now. Evaluate the sum using the summation formulas and properties. We have an upper limit here of 60, I equals 1, 7 for our guided practice. And then students, this is your independent practice down here. I'll let you do that. But for this one up here, we're going to use property 1. We have n and then c, I equals 1. So we're just going to multiply c times n here. So c times n, in that case, will be c times n, be 760, be 420. So we know that pretty much instantly because of property number 1. Evaluate in summation, example 2. Evaluate the summation s equals n, upper limit n, summation I equals 1, I plus 2 over n squared. So to do this one, I mean, this would be the basic idea here, 3, 4, 5 all over n squared till you get to n plus 2 over n squared. For n equals 10, 100, 1,000, and 10,000. So we have 3 different situations here. Begin by applying summation formulas and properties to simplify s. In the second line of the solution, note that 1 over n squared can be factored out of the sum, 1 over n squared up here, because n is considered to be a constant. You could not factor I out of the summation because I is the variable, or rather the index of the summation. So this will be our index of our summation here. Okay, so knowing that, we can, here's our original form of the summation. Then factor constant 1 over n squared out of the sum. So we're going to put this out in front, and then we end up with this here, I plus 2. So now we're going to use the property that adds our summations together. So we have 1 over n squared, and then summation upper n, I equals 1, I plus upper n, summation I equals 1, 2. So when we have that situation, we end up with this here. Apply formulas 1 and 2 now. And when we do that, this becomes n times n plus 1 over 2, and then this just becomes 2 times n here. So now we're combining properties or formulas 1 and 2. And when we do that, we will end up with this now, add fractions. So we have 1 over n squared multiplied by n squared plus 5n over 2. So when we further simplify this, we end up with n plus 5 over 2n. Now you can evaluate the sum by substituting appropriate values of n as shown in the following table. So here is our summation amount here, and when we enter that into our calculator for 10, 100, 1,000, and 10,000 by using this formula here. And see, these were the 4 quantities that we wanted to evaluate the summation for. Let's try one now. So we got here, A, rewrite the sum as a rational function, s of n, and then B, use s of n to complete the table. So we're going to use this to complete this table here. And then C, find the limit s of n down here. So we're going to do these 2 in class, and then students, this is your independent practice to come up with that. So this situation over here, when we start with that, this is our original here. We're going to pull out our 3 over n cubed out front, and then this 1 plus I squared will become this here, n plus n times this quantity up here over 6. And then when we multiply this out, we come up with this 6n squared plus 9n plus 3 over 6n squared here when we further simplify down. And then when we combine like terms together, we get to 2n squared plus 3n plus 7 all over 2n squared. Then this is what we'll use to make our table. This is our table from this expression here for 10 to the 0, 10, 1, 10 squared, 10 cubed, and 10 to the 4th. And then I'm going to let you find a limit here. Students, find the limit S of n down here. In example 2, note that the sum appears to approach a limit as n increases. To find the limit of n plus 5 over 2n as n approaches infinity, you can use the techniques from section 11.4 to write the limit as n approaches infinity. N plus 5 over 2n would equal 1/2. Be sure you notice the strategy used in example 2. Rather than separately evaluating the sums like this, I mean, we could have done it like that. It was more efficient first to convert the rational form to rational form using the summation formulas and properties listed. So we went from here to here is what we did. We went from summation form to rational form. And then we, as n, we made these different values up here to be n. So that's kind of a shortcut there. Example 3, find the limit of a summation. Find the limit of S of n as n approaches infinity. So we have this situation here, n I equals 1. 1 plus I over n squared multiplied by 1 over n. So begin by rewriting the summation in rational form. So when we do that, we can convert from this into a rational form here. So we have n, upper limit n, I equals 1, and then we have this here, n squared multiplied by 1 over n. So this would be our rational form here. So 1 over n cubed out here, we're going to pull this out here. The n cubed here, n times n squared would be n cubed. That gets pulled out in front, and then we have this here. Then we can just plug in our values into that rational form. So we have 1 over n cubed, and then we have these different formulations now. And then this becomes this massive thing here. We have 1 over n cubed, and this is n cubed plus 2n. This is n times n plus 1 over 2. And then this becomes this here, n times n plus 1, 2n plus 1 over 6. So we have this thing here now, and then when we combine all these together, we'll end up with 14n cubed plus 9n squared plus n over 6n cubed. In this rational form, you can now find the limit as n goes to infinity, and when we do that, this thing here, we get 14 over 6. When we take it to infinity, if you graph this, or if you check a table in your graphing calculator, this is what it will come out to. Into our guided practice here, A, this space here, A, rewrite the sum as a rational function. So rewrite this as a rational function using S of n. And then B, down here, we got a table, complete the table of S and n. Then C, which is yours, independent practice, find the limit of S and n as n goes to infinity. So here is our summation here, 2i plus 3 over n squared. The way to solve that is to use formulas. Again, 2i plus 3 over n squared. Our upper limit here is n, index equals 1. So what we bring out of this is 1 over n squared 2 times n times quantity n plus 1 over 2 plus 3n. That's part of your on your formula sheet. And when we work this out, we have n plus 1 over n plus 3n equals n plus 4 over n. That would be our final formulation of that. And then for your table down here, this would be your fill in here for S of n, 10 of 0, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. And that would be your evaluation there. Then down here, students, I want you to do that one. And that is 11.5 part 1, pre-calculus math, animated PowerPoint math video at AOL.com. Thank you very much.